Morning and welcome to chemistry class. Yes, how have you been faring? All the while we've been discussing carbon and its compounds. We have looked at the occurrence of carbon. Right from where we started this topic, carbon and a compound. We have looked at the occurrence of carbon. We have looked at allotropes of carbon. We have looked at the general properties of carbon. I don't know how many of you still grab it or can still remind yourself of what we've learned so far. Yeah, but if I'm going to give a recap of what we did last time, I've told you that carbon occurs as lamblac, or you call it soot. Carbon also occurs as animal charcoal, wood charcoal, sugar charcoal, and so on and so forth. Carbon occurs in its combined states as carbon 4 oxide or carbon 2 oxide. And then carbon itself have 2 or 3 types of allotropes. We have the crystalline and the non-crystalline. The crystalline allotropes of carbon, we have also said it contains, or they are allotropes of diamonds and graphite, which are the crystalline allotrope of carbon. And then we also have the non-crystalline allotropes of carbon. I told you that is the amorphous carbon. It is the shapeless powdered form of carbon. Those are the allotropes of carbon. We went further to discussing extensively on the allotropes. That is, we took diamond, looked at how diamond occurs and properties. We also did that to graphite, and then we also treated amorphous carbon. We went further to discussing the general properties of carbon. Today we are looking at another aspect of carbon which is on the board, the fuel gases. The fuel gases. This is another aspect of carbon that we also need to look at before we move on to carbon compounds, that is the carbon 4 oxide and the carbon 2 oxide. Okay, in fuel gases, now you may be wondering what fuel gases are. Of course, you know what fuel is. If you don't eat maybe for a day, you start losing strength. And if you eat and you have enough energy, one will say you have fuel your stomach. Also, there are the high. Okay, now fuel gases. Fuel gases actually contains elements or compounds in their various proportions. There are 2 types of fuel gases. The first type of fuel gases, I'll give you the note, but let me just explain. The first type of fuel gas is called the producer gas. The producer gas contains carbon 2 oxide with nitrogen gas. This contains, I'll show you how it's prepared. This is a producer gas. The producer gas. And then the other type of fuel gas is also known as water gas. Water gas contain carbon 2 oxide as well, plus hydrogen gas. Hydrogen is a atomic molecule, that is why you have to write it H2. So this is water gas and this is producer gas. And they are manufactured in a tower known as the producer. I'm also going to sketch that on the board for you. Is that clear? So now I'm going to give you a brief note on the producer gas and the water gas. And then we'll also do a sketch on the producer, which is a tower that produces both the producer gas and the water gas. Is that clear? Okay, on the board you have, there are 2 important fuel gases. Now, I've outlined them on the board, the producer gas and the water gas. Now, the producer gas constitute, I told you earlier, carbon 2 oxide and nitrogen gas. But it didn't just jump from the air. No, it takes a process before it is formed. First of all, we said this is made by blowing air over white hot coke in a furnace known as the producer. You shall soon see the producer and how it looks like. Now the producer gas is made by... Okay, now before the producer gas is formed, First of all, carbon will have to react with oxygen. Now, this is a typical example of combustion reaction. Now, carbon reacts with oxygen to form carbon 4 oxide. When carbon reacts with oxygen to produce carbon 4 oxide, now still in the tower, that's the producer now, the carbon 4 oxide produced rises up the producer along with unreacted nitrogen gas. Nitrogen gas, this is, okay, it's clear enough, to meet with the more hot coke in the middle of the furnace. Now, as the carbon 4 oxide is produced, it reacts with more of the coke in the furnace, and the hot coke reduces the carbon 4 oxide to carbon 2 oxide. So now you see how carbon 2 oxide is derived or produced from the producer. And once carbon 2 oxide is produced from the producer, that is the reduction of carbon 4 oxide by more coke in the producer, it is now collected at the top of the furnace along with unreacted nitrogen gas as producer gas. So if carbon 4 oxide reacts with the white coke, it produces carbon 2 oxide. This is the next equation you see. From the first equation is carbon reacts with oxygen to produce carbon 4 oxide, and more of carbon 4 oxide or more of the coke, which is carbon, reacts with carbon 4 oxide that is produced to produce carbon 2 oxide. Now the mixture of carbon 2 oxide with air, which is the carbon itself and oxygen and the nitrogen that are present in air, forms the producer gas. So the producer gas is a mixture of carbon 2 oxide and nitrogen in the ratio of 1:2. So this is a typical example or equation for the production of producer gas. Now you can see that it's in stages. The first stage is that carbon 4 oxide is produced. And for carbon 4 oxide, after production of carbon 4 oxide, it is then reduced by more coke in the furnace that is in the producer. And then once carbon 2 oxide is produced, mixed with the impurity from air, when carbon 4 oxide was produced at first, give the producer gas. So from carbon, it reacts with oxygen plus nitrogen. Now, oxygen and nitrogen are present in the air. If they react, they produce carbon 2 oxide and nitrogen gas. Now, I have told you earlier that the carbon 2 oxide and nitrogen gas contain the producer gas. Now, let's look at the water gas. Okay, now number 2, water gas. Water gas. How is water gas produced? Now, water gas is produced by passing steam through white hot coke in the producer. Now, I said earlier that the producer helps to produce both the producer gas and the water gas. Now, also see the equation for the reaction for the water gas. Carbon, which is carbon, is on the board. It reacts with steam. Now, steam is water in its gaseous state. That's what steam is. Water in gas, you can say vapor. That's steam. So if carbon reacts with steam, it produces carbon 2 oxide and hydrogen gas. And the constituent of water gas is carbon 2 oxide and hydrogen gas. So water gas is a mixture of carbon 2 oxide and hydrogen gas. So it is produced by reacting steam with carbon. It's as simple as that. And this reaction also takes place in the producer. So on one outlet you are taking out or tapping the producer gas. Once that outlet is shut, the other outlet is open. What you'll be tapping out will not be producer gas anymore. Rather, it will be the water gas. So both reaction takes place in the producer, which you shall soon see. Now, the reaction is exothermic. What's exothermic? Now, when we get to SS2, we'll dwell more on exothermic reaction. That's exothermic and endothermic reaction. Endothermic reaction is a reaction wherein heat is absorbed from the surrounding into the system to enable the reaction to proceed faster or take place. Whereas exothermic reaction is a process wherein heat is liberated or given out from the system into the surrounding. There are two types of reaction. For every endothermic reaction, the heat change is positive. And whereas for every exothermic reaction, the heat change is negative. You get more of that in your SS2. Okay, so this is an exothermic reaction, and this causes a drastic reduction in temperature below operational temperature. To raise the temperature back to operational temperature level, air is now passed. Are you following? Or am I too fast? Air is now passed and combustion reaction takes place. What's combustion reaction? Combustion reaction simply means, or combustion itself simply means burning. When any of the substance react with oxygen, that's combustion. That's burning, like what we explained in the first equation while we are producing the producer gas. So we say air is now passed and combustion reaction takes place. This reaction being exothermic, the heat produced now raises the temperature of the system. Full stop. Hence, in an attempt to make water gas, producer gas is also made. You seen it? So you now alternate whether to produce the producer gas or the water gas. Now, in practice, a common furnace is used to produce the two gases alternatively. Two inlets and outlets are provided. Air is first passed through the heated coke for about 7 minutes. The producer gas formed is collected through one outlet. Then air is turned off and steam is passed through for about 4 minutes. The water gas formed is also collected. You see it? Through the other outlet. And first of the passing of air and steam can thus be alternated. So we can decide to pass in air, and we can also decide to pass in steam. If you are passing in steam, of course you know you are going to end up producing the water gas. But if you pass in air into the producer, what you will produce at the end of the day is the producer gas. So let's do a sketch of what the producer looks like, and then we'll call it a day. Okay? Okay, now on the board you have the producer. This is the tour I was referring to earlier on while we were discussing the producer gas and the water gas. Now with this tour, it is very easy to either tap off the producer gas or the water gas. Now if you need to produce the producer gas, all what you need to do, close valve B's, and then open valve A. Once you open valve A, what happens? Air goes in to react with a coke, and then at the end of the day, you tap out the producer gas. Or if you are to tap the water gas, what you simply do, you close valve A, and then open valve B. Once you open these valves, what happens? Steam rather go in to react with the coke, and what you produce at the end of the day is the water gas. Is that clear? So this is the synthesis of water and producer gas. This is what is called a producer. This is the producer. That's the tour that is used in producing either water gas or producer gas. Now I want you to note that water gas has a higher calorific value than the producer gas, in that both constituents or constituents of water gas are combustible, while only one of the constituents of producer gas is combustible. Of course, if you have water gas, which is CO in the gaseous state, plus hydrogen in the gaseous state, they are both combustible. So that's why they have a very high calorific value compared to the producer gas, because nitrogen is not combustible. Nitrogen gas is not combustible, but carbon 2 oxide gas is combustible. So you expect a higher calorific value from this other than this other one. Is that clear? Now I have an assignment on the board. The assignment is write short notes on triazocarbonate 4, preparation and properties. Write short notes on triazocarbonate 4, a preparation and property. In preparation, and how is triazocarbonate 4 produced, and what are its properties, whether physical or chemical properties. Is that clear? I hope you have a nice time anyway. See you some other time. Bye.